Hi guys, welcome to today's video, which is going to be all about polarity in molecules. Now, if you haven't looked at the video around polarity in bonds, I suggest you do that first, okay? Because you're going to need to be able to identify the more electronegative atoms and draw in your partial positive and negative charges in order to work out if a molecule is polar. So a molecule is polar if it has a net direction of charge. Now, you might be like, well, that's great, but what is a net direction of charge? So what that means is you should be able to start at one end of the molecule and you'll have all the positives there, and then as you work through, you'll get to the negatives, okay? If you can do that, the molecule is polar. If you can't do that, if you go positive to negative to positive, then the molecule is non-polar. It has no net direction of charge. So I'm going to show you about how I go about working out if a molecule is polar or not. So I'm going to start off with just a couple of simple molecules. Right, let's go with water, for example, okay? So hydrogen, oxygen, hydrogen. We know the water molecule is one of the simplest ones to draw, okay? We start off by working out the polarity of each individual bond. This is why I said the polarity in bonds video is a good one for you to watch. It's only, it's not a long one, so just have a quick look at it, okay? But here, oxygen is more electronegative. So over here, we have delta negative for the oxygen, delta positive for this hydrogen in that bond. In this bond over here, delta negative, delta positive. So what you can see very clearly in this molecule is that we've got all the positives down the bottom, we've got the negatives up the top. So if we were to draw a line going here up towards the top, you would see that we start from the positives and we end with the negatives up here. So because we have a net direction of charge, water is a polar molecule. So let me show you another one that's a polar molecule. So let's go with ammonia. So ammonia, this is the ammonia molecule here, NH3, a trigonal pyramid shape. It's got a lone pair of electrons here. Okay. So we look at each individual bond. A nitrogen is more electronegative than a hydrogen. So here we have delta negative and we have delta positive for the hydrogen. Okay. So all the hydrogens are delta positive. Okay. And the nitrogen is a delta negative. Again, we've got all the positives down this side. Okay, we've got the negative up this side. So again, we can draw a line that goes from negative to positive up this way. So again, what we've got is a polar molecule. All right, let me show you a couple more. So those ones are fairly straightforward when you've only got two atoms in there. But what happens when you start to get more than two atoms in there? Okay, well, that's a very good question. So thank you for asking it. I'm going to look at something like hydrogen cyanide, okay, the hydrogen cyanide molecule. So that is a hydrogen bonded to a carbon, triple bonded to a nitrogen like this. So again, what you need to do is look at each individual bond within it. So from a hydrogen and carbon like this, okay, carbon's more electronegative. So that's delta negative there, that's delta positive there, like that, all right. But if we look at the carbon to nitrogen bond, okay, the nitrogen is more electronegative. So this is delta negative and this is delta positive here. So when we're looking at this, we might go, okay, well we go positive, negative, positive, negative. So this looks like it's a non-polar molecule. But if you put your arrows in, this bond has a direction of polarity that way, from positive to negative, okay? This bond has a polarity direction from here, from positive to negative. So you can see we have a net direction of charge for our molecule. So because we have a net direction of charge from positive to negative, okay, this is a polar molecule. You've got to remember, we're looking at polarity in a bond here when we draw up the delta positives and delta negatives here, okay? So what that means is that here the nitrogen is more electronegative. But overall we start positive, less positive, to negative, all right? So our net direction of charge is that way. So we have a polar molecule, okay? What happens though if they don't go in the same direction? And again, this is where drawing in your individual arrows can be really, really useful. So I'll show you some examples now of some molecules that are not polar, okay? So I'm going to be looking at carbon with 4 hydrogens around it. So this is methane, CH4. Okay, so we've got this molecule here, all right? Carbon is more electronegative than hydrogen, so carbon is delta negative, hydrogen is delta positive, okay? So for all of these bonds, okay, polarity goes positive to negative. So we've got, as you can see pretty quickly, all of these arrows kind of going in opposite directions and cancelling each other out. So the top and bottom ones, they cancel out. These ones coming from the side cancel out as well. So we have no net direction of charge for this molecule, okay? We can't find positives at one end, negatives at the other end. So this molecule, this methane one, is non-polar, okay? Because there is no net direction of charge in it. So what I suggest you do if you're trying to work out if a molecule is polar or not polar, okay? You draw the shape of it, okay, as you would normally, and then you start working out the polarity of each individual bond. Put your delta negative, your delta positive in for that individual bond. Then what you do, use your arrows going positive to negative, see if they all go in one direction or if they cancel out. If they cancel out, the molecule is non-polar. If they all go in the same direction, that there's a net direction of charge, then you've got a polar molecule. All right, hopefully this has been fairly straightforward for you. As always though, if you've got any questions, please write them in the comments below. And if you've got any suggestions for any other videos I should do, please write them below as well. Stay safe, I'll see you in the next video. Thanks guys.